Hello guys. If your coffee is ready, game theory is starting.
Haha, I love it.
All right, everyone, buckle up. Today, we're talking about Gravastars.
Oh, Gravastars.
Yeah, have you heard about these things?
I have.
These are like the cosmic soap bubbles of the universe.
That's one way to put it.
Yeah, they're these bizarre objects that really make you rethink everything you thought you knew about gravity and stars and the whole shebang.
They really do.
So where do we even begin with Gravastars? Like, what are we talking about here?
Well, we got to start with what we know, right? Like how massive stars die.
Okay.
They go out with a bang, a supernova.
Yeah, supernovas.
Huge explosions, and usually what's left behind is either a neutron star, which is super, super dense, like imagine cramming the sun into a city, that kind of density, or even crazier, a black hole, where gravity's so strong, nothing, not even light can escape. But Gravastars, they offer like a third option, a different path for a dying star.
Okay, a third option. So instead of becoming a neutron star or a black hole, it becomes a Gravistar.
That's the idea, yeah. Instead of collapsing all the way down to a single point, like in a black hole, the core of the star, it converts into pure energy.
Pure energy.
Pure energy. You see, the thing is, when you squeeze something hard enough, it can actually transform. And in this case, the core of the star gets squeezed so tightly that it turns into this super concentrated energy. And this energy pushes back against the outer layers of the star that are still collapsing inwards. It's like this crazy cosmic tug of war.
So it creates this shell, right? This outer shell.
Yeah,
the sources we're talking about.
Exactly. This shell, it's not like anything we've ever seen.
What's it made of?
It's thought to be incredibly thin, but ridiculously strong. To give you an idea, stretching it just 1 meter would take the same amount of energy released by an entire supernova.
That's mind-blowing.
It's mono, right? And it's also super cold, just a fraction of a degree above absolute zero.
Okay, so we've got this ultra-thin, ultra-strong, ultra-cold shell. And what's inside? What's at the heart of this cosmic soap bubble?
Okay, so inside it's mostly empty space, but it's not the empty space we're used to. Think of it like this. It's filled with this super concentrated fundamental energy, like the most basic building block of everything.
So kind of like the ultimate, nothingness.
In a way, yeah. But it's this nothingness that's bursting with potential.
Wow. All right, so we've got this weird shell, this weird energy inside. But how do we even know? How do we tell a Gravistar apart from a black hole?
That's the tricky part. From afar, they'd look pretty similar. They both warp space-time. They both have a strong gravitational pull. But, and this is the key, the way they warp space-time is slightly different.
Oh, okay. So there are subtle differences.
Exactly. And that's what scientists are trying to find.
Okay, so why bother if they act like black holes?
Yeah.
Why are we even hunting for these Gravastars?
Yeah, because Gravastars could help us solve some big problems we have with black holes. Remember that singularity we talked about? That point of infinite density at the center of a black hole?
Yeah.
Just doesn't make sense with our current understanding of physics. Infinite density, it's like a glitch in the system.
Okay.
But with a Gravistar, there's no singularity. The core is pure energy, super dense, but not infinitely so.
So it avoids that problem altogether.
It does, yeah.
Okay, what about the information paradox?
Ah, yes. The information paradox, that's another big one. It basically says that black holes seem to destroy information when they suck things in, but that goes against a fundamental law of physics that information cannot be destroyed. It can only be transformed. Gravastars, though, they might preserve information in their energy cores, so they offer a potential solution to this paradox, too.
So Gravastars, they could, rewrite the rules of the universe as we know them, but how do we find them? Are they just a theory, or are we actually out there searching?
They're still theoretical, but scientists are actively looking for them.
Using gravitational wave detectors, these are amazing instruments. They can pick up ripples in space-time caused by massive events like black hole collisions.
So the idea is that a Gravistar would create a unique ripple.
Exactly. A ripple that's slightly different from a black hole's ripple. And that's what we're looking for.
So we're sifting through all this data, looking for that one unique signal that would prove Gravastars are real.
Okay, so let's bring it back down to Earth for a second. What does all this mean for us?
Well, if we find Gravastars, it could change everything. Our understanding of gravity, of space and time, of how stars live and die, it would open up a whole new chapter in astrophysics.
It's incredible to think that something that sounds so simple, like a cosmic soap bubble, could hold the keys to some of the universe's biggest mysteries.
It really is.
It really makes you realize how much we still don't know. It's humbling and exciting all at the same time. So thanks for joining us on this journey. It's been quite a ride.
My pleasure.
Don't forget to like and subscribe. Until we see you in the next video, game over.